So imagine that you have a new objective in life. You have to find a new source of energy. This new source of energy has to be a renewable energy, a renewable source, sorry, that it means that it will naturally be replenished within a human scale. Also, in addition to that, you will have some extra points if the source that you're using comes from a material that is conventionally called waste. And also, if the process itself will produce a high value product at the time. So there is a lot of rules here, but I got your back. So let me present you for the anaerobic digestion. The anaerobic digestion is a very simple process that consists in a bacterial consumption that you're gonna feed with organic material, organic matter that is gonna easily be transformed by the bacterial consumption into biogas that contains methane, and this methane will eventually be transformed in energy. But all this process also produce a brown soup that is called digestate that is highly rich in nutrients. Normally, this digestate was used, it was spread over the crops, and since the legislation was not very restricted at that moment, and it was very well thought that the plants assimilate this product very well. But however, nowadays we know that the restrictions have increased and the plants they don't assimilate it as well as we previously thought. So what to do with this digestate? That's where the work I do in the lab now in the University Laval comes in the page. We are thinking about biorefinery. So a biorefinery, thinking about a factory that it will be fed with this organic matter in order to create methane with the biogas. Then we will install a crystallizer of estruvite. The estruvite is a biofertilizer rich in phosphorus, and then a cultivation of microalgae that will produce biomass that has a high potential to replace the whole petrochemistry industry. So the objectives of my research interest is to identify the key interactions of this whole factory with the whole process, each other interacting in themselves in order to optimize the whole process. But how? Has been two approach, the experimental approach, simulating the whole process by lab, but this will take a lot of time. So we're doing it in a modeling approach that will allow us to create in a short amount of time the same biorefinery in our computers and simulates different scenarios of it. Thank you.